Welcome to the deep dive. Today, we're going really specific, actually. We're digging into the tech specs of the Shinybow SB-3706. That's a 1x8 RCA composite video distribution amplifier.
Yeah, quite a mouthful.
Right. And our mission, really, is to figure out this sort of paradox.
Yeah.
Why does sending out a pretty low-res analog signal need such, well, seemingly high-end engineering?
It's fascinating, isn't it? The dedication to getting that older format right. So the SB-3706, basically it's a box, one input, 8 outputs, composite video.
So you plug in one source, like an old DVD player, maybe?
Yeah.
Or a classic game console.
Exactly. Or satellite boxes, cable boxes, that kind of thing. And it needs to send out 8 identical copies, perfect copies.
And I noticed it handles both NTSC and PL signals. So good for anywhere, pretty much.
Yep, global compatibility.
But here's the key question, maybe for you listening. Why not just, use a cheap Y-splitter cable? Why this solid metal box with the gold-plated connectors?
Well, that's the core of it. Simple splitting, it just degrades the signal, often quite badly. Analog video is really sensitive, divide it passively, and the quality tanks.
Okay.
So the SB-3706 uses what they call a buffered input and amplified outputs.
Buffered input, so that protects the source, like my game console.
Precisely. It isolates it. And then the amplification, that actively boosts the signal going out to each of the 8 outputs. It compensates for the loss you'd normally get.
Right, compensation.
Yeah.
And that leads to this big claim they make.
Right.
Maintaining signal quality over, 200 feet of cable?
Yeah, up to 200 feet. That's pretty ambitious for composite video. That amplification is key to achieving that kind of distance.
Okay, so let's get into the numbers that make that possible. What are the specs that guarantee quality over that run?
Well, first you look at the bandwidth headroom. The actual video amplifier bandwidth is stated as 250 megahertz.
250 megahertz
Okay.
from the pop.
Yeah, but the operational video bandwidth they spec is 110 millihertz at NAC 3dB. Now remember, the picture itself, the information, it doesn't need anything near that.
Yeah.
But you need that huge internal bandwidth.
Why? Why so much?
To keep everything clean. It prevents the different parts of the analog signal, the luma, the chroma, brightness, color from interfering with each other or distorting as they're processed and amplified. It gives it room to breathe, electronically speaking.
Okay, that makes some sense.
Okay.
Then there's this number that just jumped out at me. Slew rate, 1,000 volts per microsecond.
1,000 Vs.
That sounds insanely fast. What does that speed prevent? What's the benefit?
Smearing, ghosting. If the voltage can't change fast enough to represent sharp transitions in the picture, like, say, text on screen or a hard edge, the image looks soft or smeared. That high slew rate ensures the signal can snap from black to white or one color to another instantly. Keeps the picture sharp even at the end of a long cable.
Sharpness. Got it. And keeping it clean? The distortion spec. Nagdish 80 dBK, total harmonic distortion at 1 megahertz. How good is that number? Is that, perfect?
It's extremely low, very clean.
Right.
We're talking about eliminating any unwanted noise or artifacts added by the amplifier itself. Think of it like audio hiss, but visually. You don't want the distribution box adding electronic snow or patterns to your picture, especially across 8 displays. NACH 80 dBK means it's functionally noise-free.
Okay, clean and fast. Now, the last bit, maybe the most critical for analog video, the color accuracy checks. Differential gain and differential phase errors. Both listed at 0.03%. Tiny numbers.
Absolutely tiny and absolutely crucial. Differential gain error means the saturation, like how deep the colors are, doesn't change when the overall picture gets brighter or darker.
Okay.
And differential phase error means the actual hue, the shade of the color, doesn't shift either.
So red stays the same red no matter what else is happening on screen.
Exactly. At 0.03%, the deviation is practically immeasurable. It ensures the color is rock solid, accurate, and consistent across all 8 outputs, which is really the ultimate test of a good DA.
So what we've really uncovered here is just how much serious engineering goes into perfectly duplicating and maintaining what we now think of as a, fairly basic older video signal.
Yeah.
Especially over distance.
It's proper hardware. Metal case, weighs about a pound, built for a purpose. You see these specs, the TAA compliance for government sales, the price point around $200, the warranty. It's professional gear for a specific need.
Right. It's not just splitting wires.
Definitely not.
So wrapping this up then, it does make you think, doesn't it? If maintaining fidelity for standard definition composite video requires 110 millihertz of internal bandwidth and these incredibly tight distortion and phase spec.
Yeah, what does that imply?
What does that tell us about the sheer complexity, the data rates, the error correction, the processing power that must be involved in today's systems? Distributing pristine 4K or even 8K digital signals.
It's a completely different universe of engineering challenges. The scale just explodes, makes you appreciate the cleverness needed at both ends of the spectrum, really.
A great point to consider. Thanks for unpacking that with me.
My pleasure.